Hey everyone, today we're going to be talking about section 11.4. This is going to be covering homework number 19, and the lesson for this homework was all about arithmetic series. So let's go ahead and just jump into this thing. Alright, so for your first set of problems, it says write the related series for each finite sequence. Then evaluate each series. So I have you guys doing 1, 2, and 3 out of here. So let's go ahead and just do 4. Alright, so in this one, I gave you the beginning terms for the sequence. We've got 0.5, we've got 0.25, then we've got 0. Hopefully we're seeing, hey, we're just going down by 0.25 each time. So the next term would be negative 0.25, then negative 0.5, and then it says go all the way until negative 0.75. Okay, so if you remember from class, a series is basically just a sequence, but instead of using commas to separate each term, we're just going to use little addition signs in between each one. So just pretend like all these commas are gone and just put in addition symbols in between each term. So there would be your series. So for evaluating this thing, let's take advantage of the fact that I see some positives and negatives. So if you have a negative 0.25, that's going to simplify to 0 with positive 0.25, or they'll just cancel each other out. Same thing's going to happen with my negative 0.5 and my positive 0.5. Obviously 0 doesn't have any value to it when you are adding, so we are just left with the sum of the series just being equal to negative 0.75. Alright, for the next set, it says each sequence has 8 terms. Evaluate each related series. So in here I have you guys doing 7, 8, and 9. So let's just go ahead. I'll do 10. So on 10, I gave you that our series starts with negative 3.5. Then it goes up to negative 1.25. Then we've got just positive 1. And it goes all the way up to 12.25. And it tells you, big thing here, that there's 8 terms in each sequence. So if you remember from class, I gave you the sum of a finite arithmetic series equation, which is, if you're trying to find some sum, you're just going to take n over 2 multiplied by the sum of a sub 1 plus a sub n. Okay, so in here, all we got to do is plug in. So I know that I'm looking for the sum of the first 8 terms. So I know I'm doing 8 over 2. The first term in my sequence or series was negative 3.5. And the last term was 12.25. So when you're solving this, just make sure, follow your order of operations. I'm going to do the parentheses first. So I'm still going to have this 8 over 2 out here. And when I add these two terms together, I'll get 8.75. And then, obviously, 8 over 2 is just going to be 4. And finally, when I do my multiplication, I'm going to be left with the sum is 35. And there you go. Alright, for the next set of problems, I have you guys doing 19, 21, 23, and 24. On these, we are simply just evaluating series. So let's go ahead. We'll do a 20 together. So on 20, I'm giving you a sum that starts at term 1 and ends at term 5. Oops, let me move that down for you guys. And the sequence itself is built out of the following expression, negative 2n minus 1. Alright, so what we could do is plug in n being 1, and then 2, then 3, then 4, then 5, evaluate all of those, add them together, and get our series. I'm going to kind of use what we did on the last set of problems, and I'm going to use the sum of a finite arithmetic series equation, which says s sub n equals n over 2, and then in parentheses we have our first term plus our last term. So for this, clearly I need to figure out n, or how many terms are in my sequence. I need to figure out what the first term would equal, and I need to figure out what the last term would equal. So when we're figuring out what n is, we're just going to think to ourselves, okay, I'm going to have the first term, second term, third term, fourth term, and the fifth term. So I have a total of 5 terms, which tells me for this series, I'm going to have 5 terms in it. So I know n equals 5 equals n. Okay. And then to figure out a sub 1 and a sub n, I'm just going to plug in n equaling 1 and then n equaling 5 into the expression of our series. So if I plug in n being 1, I'm going to have negative 2 times 1 minus 1. When I solve that, I'll get negative 2 minus 1 more, and I'll get negative 3. And this was a sub 1. Then to find a sub n, when n equals 5, I'm just going to simply plug in 5 into this equation. So I have negative 2 times 5 minus 1 more. So I'll get negative 10 minus 1 more will get me negative 11. So now I've got everything I need for my equation up here. So when I'm looking for the sum of the first 5 terms, that's going to be 5 over 2 times negative 3 plus negative 11. So when we're solving this, again, just follow your order of operations. I'm going to still have my 5 over 2 out here. When I have negative 3 and get 11 more negative, I'll be at negative 14. And here, when I solve, this 2 is going to turn this into a 7. And when I do negative 7 times 5, I'll get negative 35. And there is my sum. Alright, and the second to last problem set for this homework, I have you guys doing 25 and 27. Hopefully these problems will go pretty quick for you. In the directions, it just says tell whether each list is a sequence or a series, and then tell whether it's finite or infinite. So remember, for a sequence, I'm just going to see commas separating each one of my terms. So I'll just see comma, comma, comma. For a series, I'm going to see addition symbols in between each term. And then when it's finite or infinite, basically what we're looking for here, if you have an infinite sequence or series, at the end you should see dot, dot, dot. So I have you guys doing 25 and 27, so let's just look at, say, 26. 26, I clearly see that I have commas separating each term, so I know that this is a sequence. And I don't see a dot, dot, dot at the end, so I know that it is also finite. And that's all you got to do for these problems. Alright, for the last problem, I have you guys doing 32, which is a 2-part question. So, seeing as this problem stands alone, I'll just kind of make up a sequence that is similar to, but a little different to, just to help us out here. So, let's go ahead and do a series that looks like this. 5, 7, 9, and then we'll say dot, 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 23. So, well, I gave you a sequence. On the problem, it has a series, so not a big change. Instead of the commas, I have addition symbols, and it'll look something like that. So in part A, it simply says how many terms are in the series. So for this, you're just going to have to write them out and figure out how many different terms there are. So I have 1, 2, 3. Clearly the pattern is just going up by 2. So if you just continue the pattern, just keep going up, and then we'll stop at 23. So all I gotta do is count up all of my terms. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for part A, there is 10 terms in this series. Then in part B, simply just asks us to add up all the terms, or in other words, evaluate the series. So again, I'm going to use our little formula from class for evaluating a finite series, which looks like this. Clearly, I said we have 10 terms, so I'm looking for the sum of the first 10 terms. So my n is 10. The first term, a sub 1, is up here. We started at 5. And a sub n would be the last term, or 23 here. So again, just like previous problems, just make sure to follow your order of operations. I have this 10 over 2. When I do my parentheses, I'm left with 28. Then I can do that division. And then last but not least, when I do 5 times 28, I'm just going to be left with 140. So the sum of the first 10 terms is 140. And there you go.